This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 81. Hope everybody's doing well. Your year is off to a good start. The title of today's presentation is The Impact of Satellite Data in Mesoanalysis, Results from the 2021 OPG Real-Time Severe Weather Experiment. Our presenter, Dr. Connor Nelson, research scientist and satellite researcher, GOES liaison to the OPG. Our facilitator is Dr. Dan Lindsay, GOES program scientist. Just a few reminders before we get started that the session is being recorded. There will be an opportunity for Q&A after the presentation. We are particularly encouraging attendees from forecast offices and regional headquarters to post your questions in the chat, and we will field them in the order they are asked. Also, when you do ask questions in the chat, please, if you have not signed in with your full name or you're signing in with an office account, please specify your name in the question so that if we don't get to it or there's additional follow-up, we can reach out to you. We're also looking for future presenters. So if you're interested in presenting to the Satellite Book Club, which I hope you are, please get in touch with us. And if you're looking for training materials, Brian Mott at the Office of the Chief Learning Officer can help you with that. I'd like to thank the Tower S team, particularly Kashad Bowman and Lee Byerly, Office of the Chief Learning Officer and the GOES and the JPSS program for their support of the club. Without further ado, let me introduce Dr. Connor Nelson. As I mentioned, a research scientist at CIRA. He serves as the GOES satellite liaison for the Weather Service at the Operations Proving Ground in Kansas City. His work involves the evaluation and validation of new forecasting techniques with an emphasis on satellite-dependent products and decision aids for forecasters. Connor also explores the value of advanced satellite-derived products for observing public weather hazards. Prior to working at the OPG, he was a postdoc at the University of Colorado, where he focused on observations and modeling of convection initiation. Connor, this is, I believe, your second time at the book club. Welcome back.
Yep, thank you. Yeah, thank you all for coming to this talk. So this is going to be the impact of satellite data and mesoanalysis, results of the 2021 OPG real-time severe weather experiment. For those of you who are not familiar with the OPG, we are the Operations Proving Ground, and we represent the WFO in the research to operations process. So the OPG, we're really focused in on applications of data and how it applies to forecasting and how forecasters themselves interact with each other and how they implement data in future mesoanalysis. So next slide. So at the middle of May, from the 17th to 20th May and 24th to 27th of May, the OPG conducted our real-time severe weather convective experiment. Now, our overarching goal here was to apply some lessons learned and recommendations from our 2019 Mesoscale Bootcamp. For those of you who are familiar with that or have participated in that, that was a boot camp of sorts where we really honed in on mesoscale analysis and focused in on how we can leverage mesoanalysis into operations. However, in our current experiment, we're going to be looking at integrating intra and inter-WFO geospatial collaboration with subject matter experts and a probabilistic perspective on risk assessment, and tying in a scenario-based IDSS communications for severe weather. And we had a strong focus again on mesoanalysis, but we're really focused in on the 1 to 6 hour time frame between the watch to warning time frame. This colloquially can be known as the watch to warning gap. However, the degree to which there is a gap is up for debate. That is not for us to decide. What we are really focusing on is, again, this mesoanalysis in this critical 1 to 6 hour time period before warnings are issued. Now, we were fully remote because of COVID and other reasons, so we used cloud AWIPs and other web-based resources, and we used live data, so there were no canned cases, and we were at the whim of nature to some degree. Now, throughout the progression of this talk, you may be wondering, okay, this is Satellite Book Club, I'm expecting some satellite data. And just please stay tuned. That's going to happen at the end, and then we're going to discuss how we're going to use satellite data this next year based upon this experiment. So next slide. Out of our experiment, we had 61 participants. This was an unprecedented number of participants and 16 SMEs over our 2-week period. We had 41 different WFOs, all shaded in blue on the right-hand image. Within each session, we had 14 to 16 participants with about 8 SMEs. Now, we grouped 2 participants together as a shift team, and they were paired with 1 SME. And they were going to represent a WFO under the threat of deep convection for the day. When we look at a demographic of the types of participants that we had, they were primarily early career, so a lot in the 1 to 10 year time span and often in the GS 5 to 12 range, but we did have some SUs and some lead forecasters as well, and others in the plus 10 year range. Next slide. So we took our 8 shift teams on any given day, and we broke them out into 2 groups with 4 shift teams going to each group. Each of these shift teams got assigned to be a WFO, again, under the threat of convection, and they would work in parallel. So WFO A in group 1 would be the parallel of WFO A in group 2. Within each shift team, 2 participants would play either one of 2 roles. That would be a mesoanalyst who focuses on mesoanalysis efforts, or an IDSS communicator focusing on providing routine IDSS based upon that mesoanalysis. The SME generally served in a mutual aid capacity for the mesoanalyst and IDSS communicator, and leading mesoanalysis efforts in day 1 and assisting if needed in day 2. Next slide. Now, you may be wondering, why did we have these parallel WFOs? We did this to have a data denial exercise. So group 1 had full access of observational long-range models and convective allowing models. We're going to call that the CAM group. Group 2 was the same as group 1, but they had no access to CAMs. This is going to be the no CAM group. Now, our objective was not to test the usefulness of CAMs, because we know ubiquitously that CAMs are very useful in forecasting. Rather, we were trying to assess the impact of observational data within that 1 to 6 hour time frame and focus in on data overload. Were they focused too heavily on CAMs and didn't look at the observations? Did they focus too heavily on the observations, didn't look at the CAMs, etc.? So again, we're not testing the usefulness of CAMs, rather we're focusing in on observations. Next slide. Intra-WFO communication, i.e. between the mesoanalyst, the IDSS communicator, and SME, was done through continuous video conferencing through Google Meet, and inter-WFO collaboration, aka WFO to WFO, occurred via Google Chat. Geospatial collaboration, we leveraged an ArcGIS Online, AGOL for short, dashboard, which we'll discuss on the next slide. So AGOL, we had participants, again, using cloud AWIPs to interrogate the meso environment, but we're asking them to focus on small, we're talking meso-beta or smaller areas where either hazardous severe weather is expected to occur in the next 1 to 6 hours, or convection would initiate, or severe weather is ongoing and expected to either improve or worsen within that 1 to 6 hour time frame. The mesoanalyst would then use this information and translate that into an area of concern, AC for short, drawn in AGOL. And we required them to draw 1 polygon per hour. And you'll see why on the next slide. So with that 1 polygon per hour, we then asked the IDSS communicator to translate that information into IDSS content also on an hourly basis. And we did that through various graphics or pseudo NWS chat messages. Again, the intent here was to synthesize this information provided and collaborate with this meso-analysis into a concise, digestible message. The IDSS communicator was also responsible for responding to point-based IDSS requests that we at the OPG strategically positioned in AGOL, inquiring about hazards or new developing convection. So in this example here on the right, this was one of our meso polygons issued by a forecaster, by a no-cam group in the Green Bay WFO. And you can see they're really honing in on that in the next 1 to 6 hours, we're expecting damaging winds up to 65 miles an hour, and they're indicating the area as well as an action. Next slide. Now, what information went into these AC polygons? So when drawing an AC, mesoanalysts were asked to input the following information: a start and end time, best case conditions, so think clear skies, happy days, most likely conditions, aka severe thunderstorms with 60-mile-an-hour winds, worst case conditions, tornado. They were also asked to provide a short discussion focusing in on their thoughts for the mesoscale environment, and then we afterwards would classify these polygons based upon the conditions in which they circled, either being convection initiation, being CACs, severe SACs, or improving conditions IACs. Now, what we found after the experiment was it was actually kind of hard to filter and verify these polygons when participants often use embedded words of estimated probability hedge terms. So using words probably or could happen. It was hard to verify if something could happen when we're asking, did it happen? So shown to the right here is an example of a polygon, and you can see their most likely, worst case, as well as their discussion. Next slide. Now, when we verified these, approximately 58% were classified as severe areas of concern. Now, how often did these verify? Well, to do this, we wanted to restrict the data to be within the SBC watches. So we use the SBC watch as a baseline here because we really wanted to remove any polygons where participants were circling saying, well, some pop-up thunderstorms may happen in the afternoon. We were really focusing in on these severe ones. And we verified them based upon the following criteria. Did a LSR occur within 15 miles of a SAC, or were there severe warnings within the SAC? And we did this with two verification metrics, being binary or an aerial coverage. So shown in the image here, we've got the SBC watches in red, our polygons in blue, and then in green are going to be the LSRs with a 15-mile buffer or various warnings. Next slide. So when we look at binary verification, how often did an LSR or warning just simply fall within an SAC? Well, with the CAM group and no CAM group, they were pretty similar at 93 and 88%, all groups being 91%. So there's little difference between the CAM, no CAM groups in terms of binary verification. The SACs therefore have an exceptionally high probability of detection with a low FAR. But as we see in our next slide, things get a little bit more complicated. When we do the aerial coverage, meaning how much area was covered, our size for our SACs were approximately 15,000 kilometers squared with a duration of 146 minutes, and our percent area coverage was only 35%. Now, this is a decrease in factor of 7 in size compared to the SBC watch, and a decrease in factor of 3 in time, but a decrease in factor of 1.4 in aerial coverage. So what does this mean? This means that while the probability of detection or false alarm are favorable for indicating simply the instance of a warning or LSR, much of the area within these SACs do not see a warning or LSR. Next slide. So one possible question is, did a specific event or magnitude event or day impact the metrics of verification for this aerial coverage? And the answer is not really. We saw no evidence of statistical difference in verification or other quantitative metrics of polygons. Now, there may be a relationship from day 1 to day 2 broken out into each of these sessions based upon these notch, box, and whiskers, but it's not statistically significant. So when you look at these box plots, if the notches on the sides of the box plots overlap, that means the medians are statistically similar, or the 50th percentile. So as you can see, there is this slight decrease in verification performance on day 2 when the SME took a more passive role, but again, not statistically significant. Next slide. Did access of CAMs impact? And the answer is not really. While lead time was statistically shorter for the CAM group, in time, duration, area, aerial verification were all very statistically similar. Now, let's think about possibly some other impacts which are less quantitatively measured. Let's talk about qualitative on the next slide. Through participant surveys, we did find that when participants had access to CAMs, it increased their confidence in analyzing the mesoscale environment compared to basic operations. It both validated their conceptual models and showed a range of possibilities. Now, again, note, these results are not saying that CAMs are not valuable. Rather, we are saying that our experiment yielded both unexpected and some expected results, some of which can be attributed to design, but ultimately what the CAMs do is it increases forecaster confidence, and we see that bear out specifically in the wording of the IDSS. Next slide. So we offer the following factors which may have contributed to these mixed results for verification. The experimental design may be 1 polygon per hour, may not be realistic. The newness of the activity, so for many participants, this was their first time doing mesoanalysis and providing IDSS in a probabilistic framework. This is the first time they're using cloud AWIPs, etc. NWS experience, we did have a lot more younger participants, and again, words of estimated probability. With regard to words of estimated probability, let's take a look at an example from a most likely field. Storms forming already in the area will likely tap into good instability and form tall updrafts. Very large hail may be possible with multiple rounds of storms possible in the area, and flooding may become an issue. So it becomes very hard to verify these polygons when these words of estimated probability crop up. How do you verify a probability? Next slide. So now let's get more into the satellite data and where we're going to go forward this next year based upon these results from the previous slides. When asked about various data sets in mesoanalysis and their utility, most participants felt that the following observational data sets were the most valuable. Now, we had them rank these based upon very, moderately, slightly, not, unsure, or NA. That's going to be shown on the right, and it's percentage of participants for a variety of data sets. When we rank our top 4 being above 90%, we have the SBC mesoanalysis fields at 95% being the number 1, radar imagery, surface observations, and then 4th is GOES imagery. But when we look at the group that did not have access to CAMs, GOES imagery becomes the number 1 most important thing. So regardless of order of importance, a common theme emerges where the SBC mesoanalysis fields and radar imagery are crucial in the 1 to 6 hour time frame. However, GOES imagery is highly important, especially when CAMs are removed, but maybe slightly behind radar data based on the percentage of vary in all cases. Now, the participants also noted leaning heavily on satellite data when the CAMs did not initiate convection. So again, if we do not have access to CAMs, or if the CAMs are out to launch, not initiating convection well, that is the key moment in the forecast process where GOES imagery becomes the prominent data source that forecasters use. Next slide. Now, how often was satellite data mentioned in these polygons? We had 25 polygons, or roughly 9%, that specifically mentioned satellite data. There are a lot more polygons that use satellite data, but they didn't specifically mention them in their discussion section. And our cases with the most are going to be the 26th of May, 17th of May, 18th, 19th. So let's take a case study example and actually show some satellite data from the 17th of May. Next slide. So the 17th of May, we'll do a quick brief meteorological overview. We had a deep upper level trough extending down to the southwest with appreciable diffluence over New Mexico and Texas shown in yellow. Next slide. We also had a weak surface low east of the Four Corners and strong southerly flow from the Gulf, bringing in moist, unstable air across much of the south. Next slide. We also had the formation of a dry line with pretty substantial isentropic ascent, as you can see forming here at approximately 21 UTC. Next slide. We also had considerably high surface-based CAPE and low surface-based SIN, as shown from the fields here. We had CAPE values in excess of about 1,000 into the western Texas area. Next slide. And we had steep mid-level lapse rates, which are good for hail formation as well as good for storm intensity, as shown in the orange shading here. Next slide. Now let's take a look at some satellite data. So this here is at 17 UTC, which is at the start of our analysis period. So when we look at our day cloud phase product, we can see we have some orographic cumulus start to form over New Mexico. We also have some pre-existing convection in eastern Texas, which is now producing an outflow boundary, which should spark some new convection. But when we look at the mesoanalysis, participants mainly focused in on 3 areas outlined in orange here. We're looking at orographic convection being initiated. We're looking at lee side and upper dryline convection. And we're looking at boundary layer and lower dryline convection attached to this outflow boundary. So when we go to the next slide, we should be having a GIF which is going to loop through these polygons popping up. The WFO borders are outlined in yellow. As things become valid, they will turn into a darker color. The CI polygons are in green, severe are in red. So as this goes through again, you'll see that the satellite loop highlights the ability to forecasters to see signals in our day cloud phase, this transition from greens and blues into darker yellows, etc. And they are issuing these polygons ahead of convection initiation. And they are updating them regularly. And as they start to validate, you can start to see this convection deepening. So this is one example where we had really good verification out of this experiment. Next slide. So here's an example of one of the polygons that verified quite well. So it was issued at 1846 UTC, became valid approximately an hour later with an end time all the way out to 23. Now, their most likely field, they are saying that scattered supercells have a threat for producing hail in excess of 2 inches and a few tornadoes. And in their discussion, they're already starting to hone in on some of these things that they're seeing in satellite data, such as convection initiation. And they're using mesoanalysis here to focus in on the next 1 to 2 hours for that CI to really occur. Next slide. So let's take another look at when is satellite data useful. After the experiment, we noticed an interesting theme with these polygons. When we look at data pre-CI or pre-first severe of the day, we noticed that participants often heavily leaned upon models, GOES imagery, surface observations, and the SBC mesoanalysis fields, as we've already said. Now, during that time frame, they primarily issued convection initiation polygons, no surprise, but what we have are that those areas of concern have a longer lead time and duration. After the first CI and first severe, we swap GOES imagery for radar data, and we primarily issue severe areas of concern, and our ACs have shorter lead time. So what we're seeing here is this shift in the mental distribution of forecasters, where after CI has occurred, we are now getting rid of satellite data, replacing it with radar, and we're switching into this quote-unquote warning mindset, as opposed to long-term mesoscale analysis. Next slide. So in conclusion, our verification showed that we have sort of a mixed bag of results. We have a high probability of detection, low false alarm rate for just the simple occurrence, with a low spatial coverage of about 35%. And again, this is likely owing to experimental design as well as the use of WEPs. Now, the lack of CAMs did not adversely affect the verification, with the only statistical difference being the shorter lead time, but the CAMs did increase forecaster confidence, and that bared out in the wording of IDSS as well as their polygons. Now, Satellite data comes to the forefront when cams are not available or when cams are basically out to lunch. But ubiquitously, the SBC mesoanalysis fields and radar are two of the primary things that forecasters use, regardless of whether or not the cams are initializing convection good or not. Next slide. So analysis of the events, such as our case study that we showed, as well as participant feedback, suggests that participants primarily use the following GOES products. They use day cloud phase, visible, infrared, and GLM flash extent density. They use all of this data in conjunction with the SBC mesoanalysis fields and radar to inform their mesoscale analysis. And again, we had participants heavily leveraging satellite data for CI analysis up to the first instance of CI or their first severe, switching to primarily radar with a little bit of satellite data after. And we believe this is a mental PDF switch from mesoscale analysis mindset to warning mindset. Now, unfortunately, we do not know how long forecasters had these products up for robust quantitative measures, but we plan to use this in future evaluations through tracking of what products were loaded into AWIPS and for how long. So hopefully in future severe evaluations, we can better quantify this switchover in the mindset that we are seeing. Next slide. So in future work, we are going to conduct a more full-scale case study analysis of all the days during the experiment, very similar to the case study that we showed here in this talk. And we're going to be focusing on signals in the satellite imagery and RGB products prior to the issuance of ACs to give us some sense of what forecasters were looking at. Again, because we didn't track their data, it was very hard to pinpoint exactly how long, but we're going to be able to dissect some of that to some degree. And we're also going to be dissecting their ACs, noting any specific satellite-based signals. We ultimately want to develop a playbook for satellite data, leveraging work by Chad Gravel from his paper in 2016 for use in future OPG evaluations. And our big pie in the sky dream as we go forward into this next year is we would possibly like to hold an open session where forecasters can get more at-bats, so to speak, practicing mesoscale analysis and joining the OPG using AGOL and testing various forecasting techniques. Rather than having a dedicated 2-week experiment, this would allow forecasters to join in and basically play with cloud AWIPS and play with AGOL to some degree. So next slide. So I want to thank you for listening to my talk. My contact information is at the bottom of the screen. If you are interested in more information about the experiment itself before this satellite component, I'm going to drop a link into our ArcGIS map that you can play around with. It does require CAC or NOAA LDAP credentials, but it gives you a sense of what our motivations were for the experiment. And if you're interested in this talk, I'm going to be giving a smaller version of this at AMS next week. And with that, I'll take any questions.
Great. Thanks so much, Connor. Very nice presentation. I would like to encourage everybody to stay on. I know we're 30 minutes in, but we are going to spend the next 15 to 30 minutes answering questions. So everyone, please type your questions into the chat, and we'll go through those in just a couple of minutes here. We strongly encourage participation from any actual Weather Service forecasters, either from the WFOs, the regional headquarters, or national centers to participate. One quick advertisement: a week from today, Thursday, January 27th at noon Eastern, Dr. Bob Rabin from NSSL will discuss nowcasting storm intensity from satellites. So please join us for that Satellite Book Club. Also, contact the Tower S team. That would be Lee Byerly and Kashad Bowman for questions about Satellite Book Club or for configuration of satellite products. And then finally, one more reminder to type your questions into the chat, and we'll start going through those now. All right, let's go. So I'm going to take a couple from the chat first, and then I may have a couple of my own. Scott Lindstrom is wondering, early on in the presentation, you mentioned GOES without specifying what instruments. At the end, though, you did mention the use of GLM flash extent density. So I guess the question is, when you were using the term GOES early on, were you referring to ABI or ABI and GLM both?
So I was referring to both. So we collectively use the umbrella term GOES, basically meaning ABI, GLM, derived RGB imagery, etc. That was basically an all-encompassing term to try to simplify the survey a little bit for the participants.
Did you also look at the ground-based lightning networks that were available, or was it only GLM for the lightning data?
So participants did use ground-based lightning. However, when polling them, we primarily focused on GLM.
Okay, thanks. So Ross is wondering, did you look, or was prob severe available as another data point?
I do not believe it was.
Okay, thank you. Steve is asking, regarding the mental switch that you were talking about for young forecasters, do you think that reflects the WDTB training in DLOC? I think there may be new acronyms, but I think we know what we're talking about, the radar course.
Yeah. So, with the, I believe like the rack training course and things like that, I believe there may be some degree where the youngness of the forecasters did bear some fruit there. But I also think that as, quote unquote, weather nerds, we often gravitate towards seeing radar signals, and we're so excited. And, it gets our adrenaline pumping when we start to see those first convective echoes manifest into something deeper. So it's hard to stop wish casting at that point. Not to make light of severe weather, but when we do have this development of severe weather, we do tend to focus more heavily on radar data naturally because it gives us a lot of information, especially dual pol. But again, we have this whole situation where we had forecasters sharing radar imagery inside of our chat rooms, and they started gravitating towards more nowcasting instead of longer term mesoscale analysis. So I think it may be a couple of things hammering out there.
Yeah, and regarding the sort of focus on radar after the storms form, I remember a few years ago, and I don't remember who, it might have been the Omaha office, or maybe it was OPG, was looking at having a dedicated mesoanalyst. So even after storms form and warning mode is started, they have forecasters focused on issuing the warnings, but then they also have a mesoanalyst whose job is to sort of focus on the satellite and the observations, and then provide info back to the warning forecaster. Like, this supercell, which of course has a severe warning now, is moving it into an environment which may cause it to weaken, that kind of thing. Did you talk about that at all, or was it more of just the single forecaster sort of looking at all of the available tools that were out there?
Yeah, so our SME again was basically this mutual aid capacity, and they were supposed to serve as a constant mesoanalysis resource for the participants. And I believe our SMEs did a really good job of trying to steer them back towards that aspect. But at the same time, we also tried this split of roles, so to speak, where we had a true mesoanalyst out of the participants, as well as an IDSS communicator. And we tried to see whether or not the workload was either too much or too little on either person. And what we found was that when we talk about operations, it may not be feasible to do this the way operations is currently structured, just due to staffing and the amount of workload that forecasters have on a day-to-day basis. So to answer, long and short, yes, we did consider that, yeah.
Yeah, great, thanks, Connor. All right, let's move to more questions. Pete says, in future experiments, I think it's very important to understand the training and experience level of the participants. Those less experienced likely to depend more heavily on SBC mesoanalysis page, which of course can have error since it's reliant on the wrap, than more experienced forecasters. I think this is important when trying to interpret results. So that was a comment, but I'll stop and let you reply to that if you'd like to.
Yeah, no, that's a very, very great point. And that's something that I can probably really easily do looking at these survey results and just basically re-rank it based upon experience. That is something that I will look into. But one also caveat, we actually did try to see did verification improve or worsen based upon the experience. The problem is that these are often so collaborative in nature that it's hard to say what is the collective experience level when you have maybe a lower GS level paired up with a higher GS level paired with a SME that's been around for 15 years. So it becomes really hard when you're collaborating in that aspect.
Yeah, and Pete brings up a good point about the mesoanalysis page being prone to error. That's been the case for years, of course, and anytime you take surface analysis and put wrap data over the top of it, you're going to end up with some inconsistencies. And I think a lot of forecasters, especially less experienced, may take it as truth, and it's not necessarily truth. And I really think that's an area that's ripe for research of maybe finding ways to improve the mesoanalysis and find something that's even better. All right, Scott is asking, how much did the experience of the SMEs drive the results in the experiment? I noticed, for example, that JPSS data was not mentioned. How fluent in JPSS channels or NuCaps profiles and gridded NuCaps were the SMEs?
So some SMEs were more fluent in NuCaps than others. With that being said, I think all of our SMEs had some experience with NuCaps. The degree to which did vary. With regard to specifically asking JPSS questions, when we designed the survey, we were primarily trying to focus in on more broad uses for data. And I think this may have been something where we probably should have more specifically said, which satellite products do you use NuCaps, etc. So that's something to keep in mind for future evaluations. As far as how much did SMEs drive the results, when you look at our notch, box, and whiskers, where the SMEs were on day 1 doing a more active role and on 2 doing a more passive role, you do see a decrease in the verification results. But again, it's not statistically significant. So whether or not that would become statistically significant with more data, that's something that we would have to do more evaluations and collect more data to really confidently say that.
Thanks, Connor. So next, I want to remind everyone to please share any feedback that you may have. Lee posted a link to the feedback form in the chat right at 10:30 my time, at least Mountain Time. So go through and click on that link and provide us feedback if you would. There are a few more questions if those who can stick around. Anita asks, was there any use of the sandwich satellite products?
Long story short, absolutely. More complicated answer is we had a hard time quantifying how long the participants looked at certain products. And then when you ask them afterhand, how long did you look at this product? It's hard for them to correctly gauge how long they looked at product X versus product Y. Because what they believe they looked at may not actually be correct. So again, this is one of the things where in future evaluations, we want to more quantifiably track what products they have loaded up in Cloud AWIPS.
Yeah, and on the topic of the products, I've noticed increasing every time we have one of these presentations, it seems like the day cloud phase RGB comes up. That's one that when we first launched GOES 16, we didn't use at all. And it's gone from zero use to like ubiquitous use, which I find really interesting. And in some cases, instead of the Viz, I think. It is worth noting that this is a relatively coarse product in resolution compared to just the band 2 visible. If you zoom in far enough, at the scale of the image in the background here, it's fine. But if you start zooming in on literally storm scale, it may get a little bit blocky. So it's a great product, but keep in mind that the band 2 visible is even better resolution. All right, so Pete, yeah, sorry, I'll let you respond to that if you'd like to.
Yeah, real briefly, yeah. We really see the day cloud phase in that pre-CI time. That is something that participants did give us feedback on.
Yeah, and just a quick follow-up. Did you look at any after dark cases?
No, so all of our times ended before dark.
Yeah, there's no question that those visible bands are pretty important for help with the satellite analysis. I mean, certainly infrared gives you good information too, but not as good as the vis. Okay,
Right.
yeah. Pete says satellite is great until it's not. Did you have any cases with widespread mid and high level cloudiness that hide the key features? Did that lead participants to shift away from satellite? He says it does for me at times in the mesoanalysis mode.
So we did. We had a couple of days where there was pretty decent cloud coverage. It made it very hard to see things. We had convection that was already ongoing and pretty widespread by the time we started. And when we did the verification, those days were often kicked out. And that's something that I want to investigate a little bit more, is how did those polygons look and what information was inside those polygons on those days. And that's what we're going to do with this case study analysis that we're going to do this next year.
Thanks, Connor. Anita commented that she agrees with Pete, even in the CI timeframe. I think that's referring to the, when you get high cloudiness that can hide things. And then Anita also asks, how did the shift to more radar, less satellite impact the IDSS message?
So what we saw in the IDSS message was, again, we saw the shortening of duration. We also start to see wording that more resembles what we would see in a warning, as opposed to some longer term mesoscale analysis. So those were the two most tangible things that we could infer from the IDSS.
Thanks. Bill asks, he states, but the day cloud phase distinction RGB includes channel 2 vis and an AWIPS at least. So he's correcting me. Thanks, Bill. So yeah, I guess if they're displaying it at 500 meter resolution, that means it probably maintains some info about the high resolution vis, and it's not actually at 2 kilometers. So apologies for my incorrect statement earlier there.
So I would have to go back and look at my code. So all of my RGBs I'm plotting here, I actually made in Python and not AWIPS. And I do believe I do have it at the 500 meter res on that channel 2.
Yeah.
Basically, it's just resampled to get it to that resolution.
Yeah, that's great, because that's the best way to do it. It would be even better if we had all of the channels at 500 meter resolution, of course, but we know that that's not going to happen. Okay, well, that's the end of the chat. I'm going to give everybody one more minute or a few more seconds rather, to put anything else in the chat. And I think that got all of my questions as well. Let's wait. So one more reminder to come next week to hear Bob Rabin talk to us about on the 27th, same time. And a reminder to fill out the survey that Lee posted. So I guess we'll go ahead and conclude now. Thanks very much, Connor, for a great presentation, and talk to you again soon.
Okay, thank you so much, Dan. Thank you so much, Connor, and thanks to everybody for attending today. As a reminder, you can get in touch with our Tower S team, Lee Byerly, Kashad Bowman, if you have any questions about the Satellite Book Club or about the configuration of satellite products. As Dan mentioned, I hope you'll join us next week. We will be continuing, despite the fact that some of you may be attending the American Meteorological Society annual meeting virtually. And if you're not able to join us, we'll have that talk posted online shortly afterwards. With that, I hope everybody's staying well, and take care.